All right, hey guys, welcome back. This is going to be your lecture for lab 3. I'm sorry this one's coming out kind of late. I had some issues with Zoom and YouTube over the weekend. So hopefully I'll finally get this out. And then I will post this PowerPoint with everything I say under the notes section as well. So if you don't have time to watch the videos, you can easily still look at the PowerPoint and get all the stuff that I'm going to tell you in the video. So this is lab 3. Today we're going to go over an intro to the skeletal system, the skull and the axial skeleton. So for exercise 8, you're going to need to be able to identify the functions of the skeletal system, locate and identify the 3 major types of skeletal cartilages, name the 4 main groups of bones based on their shape, and identify the cellular structure of compact bone and how bone is formed. All right, so there are 5 main functions of the skeletal system. The most obvious ones are support and movement. Bones allow us to support ourselves in different positions, and muscles are going to pull on our bones, which so then act like levers to allow us to move. The skeleton is also going to protect our body. Our brain is protected by our skull, and our heart and lungs and other vital organs are going to be protected by our thoracic cage or the rib cage. In the storage, you're going to refer to minerals, mainly calcium. That is kind of where we get the idea of drinking milk to build up strong bones because milk is rich in calcium. Hematopoiesis is just the production of blood cells, mainly red blood cells and some white blood cells. So the skeleton can be arranged into 2 major groups, the axial skeleton and the appendicular skeleton. Today we're going to focus on the axial skeleton. Next week we'll go over the appendicular skeleton a bit. So the axial skeleton is the image on the left and is composed of the skull, the vertebral column, known as the spine, and the thoracic cage or your rib cage. The appendicular skeleton is on the right and is composed of the upper and lower extremities, so your arms and your legs. And again, we'll go over that next week. Another thing on this slide, so I know it says there's 206 bones in the body. You do have to know all 206 bones, but I promise you it's not as scary as it thinks. One thing I use to help me really is I remember that the body is symmetrical. So if you split the body down to half, that's already 103 bones down. And then the next easy way to do it is to remember it in groups. So I'll kind of go over that once we get into lab and how you can do that easily. So figure 1.8 in your book is the first know everything slide we have in this lecture. And then note that the axial skeleton is the bluish color and the appendicular skeleton is that kind of tan typical bone color. Um, you will see this image again. I will ask you about some of the bones on here on your practical. Um, and then do make sure you look at kind of the brackets. So you see in the skull is composed of the facial bones and the cranium. There's a couple of bones that make up the cranium, so make sure you guys know that. And then know that the vertebral column stretches from base of the skull all the way down to your tailbone, which is called the coccyx. Um, and then yeah, I won't really go over the appendicular skeleton today. I'll do that next week. So next we have our 5 categories of bones. And the category is going to be based on shape, similar to how we split up cell shapes. We have the 3 cell shapes. We have 5 bone shapes. So long bones are going to be mainly made of compact bone, are going to be very thick. They're going to have a roundish knob on each end of the bone. A good example of this would be your humerus, your femur, or the phalanges. So your humerus is your upper arm bone, kind of where your bicep is. The femur is your thigh bone, and then the phalanges are the bones that make up your fingers and your toes. Short bones are going to be cube shaped. Example of these is going to be the carpals of the wrist or the tarsals that make up the ankle and heel area. Flat bones are going to be flat and wafer-like. You can think of them as like a sandwich. So it's going to be spongy bone in the middle, and then on the ends going to be a compact bone layer on either side. Flat bones also going to be very thin, and flat bones are going to be found in the skull and in the sternum or your like middle chest bone. Irregular bones are not going to have a very specific shape, but they're going to be highly specialized cells, or not cells, specialized bones. And a really good example of this is going to be your vertebra. And then lastly, we have sesamoid bones, and they're going to be smooth, round, and circular. They're also known as floating bones because they're going to be found embedded in tendons and ligaments. The primary example of this is going to be your patella or your kneecap. So I'll do a quick review on cartilages because we did do those in the first section of the lab. So we know cartilage would help reduce friction and help cushion impact. Then we found at joint articulations, which is just where two bones come together to make a joint. There's no nervous structures and there is very little vasculation, so there's no nerve endings, there's no blood vessels running through um, cartilages. I shouldn't say that. There are some blood vessels running through cartilage, which is very little. And then cartilage is going to repair itself via the outer covering known as the pericardium. So if you think peri means outer and then chondri is cartilage, that's how you get perichondrium. So then the three types of cartilage that we're going to see in the skeleton is we have hyaline cartilage, which is going to be your articular surfaces. So where you have joints, your costal cartilage, which is going to be where your ribs attach to your sternum. Respiratory is going to be in your respiratory system, so your throat, and then your nasal cartilage is so your nose. And then we have elastic cartilage again, which is going to be in your ear and your epiglottis, which is another structure in the throat. We'll worry about that later on. And then lastly, we have fibrocartilage, which is going to be in between your intervertebral disc and your meniscus in the knee, and the pubic symphysis, which is a joint in the middle of your hip. So next, we're going to go over the bone markings. These are sites that muscles, tendons, and ligaments are going to attach to. There are also going to be openings where blood vessels and nerves can run through, and they can be used to help identify what bone you're looking at, and what direction. For these, I'm gonna go through all of them today in this lecture, but when we get into lab, I'll give you kind of a more specific ones of which ones I want you to really focus on. And then with that, I'm only gonna ask that you know kind of the definition and description of each one. I won't really ask you on the practical like name this specific bone marking on the bone in lab. So this table shows the first category of bone markings, which is projections. These are going to be sites where muscles and ligaments attach. These projections are going to be pieces of bone that are going to be growing out of the main structure of the bone. And then on this table, I'm going to go from bottom to top. That way we can work from the more simpler um, bone marking to the more complex. So at the bottom, we have a process. A process is just going to be a little bump on the bone. It says that bone prominence is really just a tiny bump on the bone. You can see, just kidding, it's not labeled on either of these images. Okay. A spine is exactly what it kind of sounds like to be a sharp, slim, and pointy projection. So a little bit bigger than the process. It's going to be really sharp. So that's going to be the key thing there is it is sharp and slim. You can see a spine here on the pelvic bone. That is what they're going to look like. And you also have spines on your spine. So if you run your hand down your neck, you can kind of feel them at the base of your neck, what kind of where your back meets. That is going to be the spine of one of your vertebrae. An epicondyle is going to be a raised bumper projection that is above a condyle. I'll go over what a condyle is a little later. But just know that an epicondyle is usually where you're going to have some cartilage and where you're going to have another joint articulation. A tubercle is a small rounded projection. So it's kind of similar to a process, just going to be a little bit bigger. A line is just a narrow ridge that goes along the length of a bone. It's really like that simple. It just looks like a line on a ridge. Trying to think of like if you look at a map, you see like a mountain range. It just looks like a line that's kind of raised along the surface of a map. It's gonna be kind of like that. A trochanter is a large blunt process that can only be found on the femur. So if you look at the image on the femur, you have two trochanters labeled. That is because there are two different trochanters on the femur. You have the greater trochanter, which is the bigger one on top. And you have a smaller trochanter known as the lesser trochanter, which is on the one on the bottom. Next, we have the crest. So the crest is going to be a very prominent narrow ridge. You see in the example, we have the iliac crest because that is on the ilium bone of the pelvis. So the crest is usually going to be named after whatever bone it is found. Crests and lines are similar. The main difference is going to be the crest is much bigger. And then the last one on the slide we have is a tuberosity. A tuberosity is a large rounded projection that is usually very rough and bumpy, and it may have divots similar to like the divots on the surface of a golf ball. So next category we have are projections that help form joints. One word you hear me a lot of me talking about in these next couple of lectures is the word articulation or articular. That just means, again, that there's going to be two or more bones coming together to form a joint. And remember, where we have a joint, we're also very likely going to see hyaline cartilage, which is going to be more specifically articular cartilage. So first we have the head. The head is going to just be a bony expansion that is connected to the main bone by a narrow neck, similar to how our head is connected to our body by our neck. Next is the facet. It's going to be a smooth surface. That's actually going to articulate with another bone. The facet is almost always going to be found on the head of a bone, and you could typically see a white layer of that articular cartilage on top of a facet. All right, next we see the condyle. The condyle is going to be another projection where the joint will articulate or be formed. Compared to the epicondyle, where muscle attaches to bone, the condyle is going to where bone attaches to bone. And then last, we have a ramus. This is just an arm-like projection, and it's found on the mandible or the jawbone. It extends down from the condyle of the jawbone down towards the chin. And then you see the condyle on the jawbone. This is what's going to allow you to move your jaw up and down so you can talk and eat. So the last category we have are depressions and openings. If you notice at the bottom, the last three are listed as other because they don't technically fall into a specific shape like the others do, but they are going to still be depressions and openings. So the first three markings are going to be used to allow for the passage of blood vessels and nerves. So first we have a fissure, which is simply a narrow like opening. And you can usually find those in the eye socket of the skull. Next is the foramen or foramen. People say it differently. So I usually say foramen. That's just how I was taught it. And those are just something a round or oval shaped opening through a bone. They're not labeled on this image, but you can see there are two foramen just below the teeth, right in the front of the jaw. Those are known as your mental foramen. Don't really worry about that too much. That's just an example. I'll probably won't ask you that on a practical. And then there are also two more small foramen just below and above the eye socket. Again, don't worry about that too much. You probably won't hear that again. Next is a notch. So a notch is an indentation on the edge of a structure. On this image, there is a small white notch at the end of the mandible. You can kind of see it there labeled. And then now we'll go over the others. So a meatus is a canal passageway similar to a foramen. Um, on the example here, we see the external auditory meatus, and this is kind of where your eardrum is going to connect to your brain so we can hear things. A sinus is a hollow cavity that is filled with air and then lined with mucus. So that's kind of the thing in your face when you kind of feel kind of sick, you feel like you have a sinus headache. That just means that that hollow cavity has been filled up with too much fluid. So you have a lot of pressure in your face, in your head. And then lastly, a fossa is just a shallow depression that sometimes serves at the articular surface. So there's really only two big ones you're going to need to know. One is the glenoid fossa. That's where the humerus attaches to the scapula. And there's another fossa in your hip where your femur connects to your pelvis. But again, that's more appendicular stuff. So we'll go over that next week. All right, so this figure shows the anatomy of a bone. So this is a long bone. So we see here that we have a diaphysis in the middle, and then on the ends we have two epiphysi, two epiphysi. Yeah, sure. So this figure shows the anatomy of a long bone. So we have the diaphysis, and it's going to be the long body of the bone in the middle. And then we have the epiphysis, is going to be the ends of the bone where they attach to another structure, usually another bone. Notice that there is a proximal and distal epiphysis. So one's going to be closest to the trunk and one's going to be further away. So this image is a picture of the humerus. So the proximal epiphysis is going to where your upper arm connects to your shoulder. And then the distal epiphysis is going to be kind of where your elbow is and attaches to your forearm. The bone is also composed of several layers. The outermost layer is called the periosteum. This is a covering made of connective tissue. And then deep to the periosteum is compact bone, and then deep to the compact bone is the medullary cavity, which is where bone marrow is stored. And then if you look at the dissection image on the right, you can see how the periosteum is a really thin fibrous covering layer that covers the compact bone. And you can also see the hyaline cartilage that covers the epiphysis and where bones are going to articulate to form a joint. Also note that within your epiphysis, you're going to find spongy bone. It's going to look like a sponge. It's going to allow for a network of blood vessels and nerves to kind of run through. It's going to be a lot softer than your compact bone. So this image is of the structures that can be found within compact bone. The circular units that make up the rings we associate with bone tissue are called osteons. Osteon is going to be what provide the structural strength for compact bone. And then within each osteon, there's a hollow structure called the central canal. And the central canal, again, we went over this before, but it's what allows blood vessels and nerves to run through the compact bone. And then the individual rings that surround the central canal are called lamellae. Once a group of osteons come together, more rings will form, and these are going to be called the circumferential lamella. And circumferential lamella are responsible for grouping osteons together in the center of compact bone. Interstitial lamellae form in the dead spaces in between each osteon, and then similar to the lacunae found in cartilage, bone is also going to have lacunae that house the osteocytes that create bone tissue. You can kind of see the lacunae and the osteocytes in the bottom left image. All right, so this diagram shows how long bones grow. In the top of the image, you see a white layer within the epiphysis of a long bone. That's called your epithelial line or your epithelial plate, or better known as your growth plate, which is going to be found in immature bone of children and teens. After puberty kind of ends, the growth plate fuses and comes the epiphyseal line, and it's just going to be solid bone. So bone growth happens in four layers. So if you remember how the integument system grew up in layers from bottom to top, bone kind of works in the opposite direction. It goes from um, outside in and pushes cells down instead of pushing them up. So in the first zone, we have the proliferation zone. This is where cartilage cells are going to see rapid mitosis and grow quickly and divide rapidly. Next, we have the hypertrophic zone, which is where the cartilage cells are going to grow bigger. Because again, hypertrophy just means to grow in size. The third zone is called the calcification zone, and this is where the cartilage cells are going to start to calcify and solidify, and then eventually die. And then lastly, in the ossification zone, this is where the dead and broken down matrix of the calcification zone are going to come together and form that dense bone tissue. For this slide, really just know the four zones and kind of like a brief overview of what's happening in each zone. Again, I'll probably go into more detail once we get in the lab because I know this lecture is coming out kind of late. All right, so that's that for the projections, bone markings, bone tissue kind of stuff. Now we're going to go into the actual bones of the axial skeleton. We're going to start naming the bones, identify the different bones and landmarks of the skull, identify different types of vertebrae, and then look at the difference between an adult and fetal skull. So once again, the axial skeleton is made up of the skull, the vertebral column, the thoracic cage, and the hyoid bone. The skull is composed of several bones that make up the cranium and then the facial bones. The vertebral column is made up of 24 vertebrae as well as the sacrum and the coccyx. The sacrum is going to be 5 fused vertebrae and the coccyx is 4 fused vertebrae. The thoracic cage is going to be 12 pairs of ribs. And finally, the hyoid bone is a floating bone and is found in the throat and held by a bunch of ligaments. So this slide is a reference guide that kind of help you study all the different bones of the skull. It's color coded, and the colors match the images we're going to look at later in the PowerPoint. And then all the images later in the PowerPoint are also color coded and they're all corresponding. So if you look like a different view, the bones are still colored the same. So really look at this when you're studying the bones of the skull. So we're going to start with this view, which is just a regular interior view of the skull, because that's what you're most likely already familiar with. Note that everything that has a red box over it, you don't need to worry about. And then again, I'll say I will probably only ask you about the major plates of the skull, probably the mandible and the maxilla, and maybe a couple of the facial bones. For the video, guys, I just want to make sure you guys know that kind of basic stuff on the skull. Um, yeah. So first we have the frontal bone. It's going to make up your forehead area. Next, we have the two parietal bones. Going to be on the side next to the frontal bone. Then we have the temporal bones, which are going to be on the sides where your temples are. And they're going to be below the parietal bones. And we go towards the nose, we see the zygomatic bone, which forms your cheekbones, and it's going to connect to the maxilla, which is your upper mouth. And then we have the mandible, which is going to make up your jaw and lower mouth. All right, next we'll go back up towards the eye socket. So inside the eye socket, we have a superior and inferior orbital fissure. We also have the optical canal where the optic nerve runs to connect the eye to the brain. And lastly, we have the nasal bone, which is just the kind of the bridge of your nose. And then we have the lacrimal bone, which is going to be the green color on the inside. And that's where you're going to find your tear ducts. So this is a lateral view of the skull. You can see again that external acoustic meatus we talked about earlier, looking at the temporal bone in the orange color. There's also a few processes on this temporal bone, such as the mastoid process, which you can feel right behind your earlobe, kind of on the back of your head there, kind of right in between, like where your jaw and your skull kind of meet. That's going to be your mastoid process. And then you can also see the styloid process. Stylo means like a pen or stylus, and it kind of looks like a stylus or pen you would use for your iPad or writing notes. You can also see the condylar process at the top of the mandible, and then you can see the mandibular ramus, which we talked about earlier, extending down towards the mandibular arch, which is kind of like your jawline. And then again, we see those mental foramen I mentioned earlier located towards the chin. Again, don't really worry about that too much. So above the temporal bone, you see the parietal bone again. And anytime you see the flat bones of the skull come together, they'll be fused by a suture, which is just a really tight, immovable joint. The parietal and frontal bone are joined by the coronal suture, which lies in the same plane as the coronal plane. These sutures are not solid at birth, and what causes these soft spots on a baby's skull. So this is a cadaver image. I will not ask you to know this on your practical as an image wise, but you will have to be able to look at one of the figures in the lab that's not colored and kind of tell me what bone I'm asking for. So if you can just really focus on these and kind of know where they are in the colors and then just kind of identify the same bones on this, that's perfect. You won't see this image on your practical, but you might have to just identify one or two bones on the model. So this is an inferior view or bottom view of the skull. So right in the middle, you can see the foramen magnum. You will need to know that. And it's on the occipital bone. And this is where the vertebral column meets the skull and allows the spinal cord to meet the brain. And I will say when going through and trying to identify the different bones of the skull, it's easier to identify key structures like the foramen magnum and then identify which bone it's on. So again, the foramen magnum is going to be on your occipital bone, which is the bone in the back of your head. And then also on the occipital bone, you can see there's a label at the very bottom. Is the external occipital protuberance, which you can feel in the back of your head. There's like a little bump kind of right above where your spine meets your head. That's your external occipital protuberance. All right, towards the interior part of the skull, kind of back towards the teeth, you have the hard palate, which is composed of a couple of different parts. You have the palatine process, the maxilla bone, and you have the horizontal plate of the palatine bone. Trying to get those two confused. I probably won't ask you about them really specifically, but just know that there are two different ones. Palatine bone is on the or horizontal plate is on the palatine bone, and the palatine process is on the maxilla bone. I don't know why I named it like that. I think it's stupid, but you know. You can also see a very good image of the vomer and sphenoid bones, which are typically described as having a butterfly shape. The vomer is going to what makes up that body of the butterfly and is here in the blue in the middle. And then the sphenoid bone is going to make up the wings of the butterfly, and it's that pink on either side. Again, this is another cadaver image. You won't see this image when are practical, but do know kind of how you can identify certain bones, mainly just the occipital bone and the foramen magnum from this image. And then this is an internal image of the skull. So if we cut it kind of on a transverse plane. You look down from the top. You can finally see the whole sphenoid bone, or we can see the greater and lesser wings of the sphenoid bone and the silica turrica, which is the body of the sphenoid bone. So like the middle here is the silica turrica, and then we have our lesser wings and then our greater wings. And then you can finally also see the ethmoid bone, which is the anterior portion of the skull. It has the cribriform plate and the crista galli, which is a spinous process. Don't worry about that too much. And then the cribriform foramina are also just tiny holes within the cribriform bone. The hypoglossal canal can be found on the inside of the foramen magnum, which is where the hypoglossal nerve runs through. And again, this is another realistic image of the inside of the skull. And this figure is just for reference. I think it looks kind of cool. You can really see the butterfly shape of the sphenoid bone. This bone is a really complex bone and it's very important for holding the facial bones together. All right, so finally we come to a posterior view of the skull. You can see the sagittal suture joining the two parietal bones together and also again along the sagittal plane. You can also see the lambdoid suture, which connects the occipital bone to the two parietal bones. And then again, we can see those two occipital condyles where the skull forms a joint with the vertebral column. And then finally, the external occipital protuberance is the pointed process coming off the occipital bone, and that's kind of where that bump in the back of your head is. And then lastly, we have the occipital mastoid suture, which joins the mastoid process to the temporal bone. Sorry. We have the occipital mastoid suture, which joins the occipital bone with the mastoid process of the temporal bone. All right, so again, these next two slides are just going to help you study their reference guide, and it shows what bone is colored, what color, and kind of a description of each bone. Kind of help you make it identifying a little easier. This is the hyoid. Sorry, no. Yeah, these next two slides are just tables to help color code the bones for you and help identify the bones easier. So it's this one and this one. All right, so this is the hyoid bone. Again, it does not articulate with any other bone in the body. It's in the front of our neck and it has a greater and lesser horn and the main body located in the middle. I'm not really sure why we have this. I think it's because if you get hit in the throat, it kind of protects us. But I'm not really sure. All right, so now we're going to move on to the vertebral column. So there are 24 vertebrae plus the sacrum and the coccyx. So the vertebrae is broken up into three main parts and then the two subparts. So the three main parts are going to be your cervical, your thoracic, and your lumbar vertebrae, or curvature, they're called. So the first seven vertebrae, C1 through C7, are going to be your cervical. Your thoracic is going to be T1 through T12, and then lumbar is going to be L1 through L5. And then at the bottom, we have our five fused vertebrae, which make up our sacrum. And then lastly, we have our four fused vertebrae that make up the coccyx. The easiest way to remember what order and how many vertebrae in each section is to think about the times that we eat food. So we eat breakfast at 7, so the cervical has 7 vertebrae. We eat lunch at 12, thoracic has 12 vertebrae. Dinner at 5, lumbar has 5 vertebrae. And the last two, 5 plus 4 is 9. 9 p.m. could be your late night snack. But do remember that sacrum has 5, coccyx is 4. So again, breakfast at 7, lunch at 12, dinner at 5, late night snack at 9. And so that's 7 cervical, 12 thoracic, 5 lumbar, 5 sacrum, 4 coccyx. Do know how many vertebrae are in each. Know the direction that they're in, or not direction, the order that they're in. So cervicals first, then thoracic, then lumbar, and then again sacrum and coccyx. I wouldn't, and then you will not have to know anything about specific numbers of vertebrae except for the first two cervical vertebrae, which we'll go over here in a second. So this figure shows abnormal spinal curves. Um, this image will be on the practical, so know this, be able to tell me which one's which. So scoliosis has a lateral curve, so kind of like that S pattern curve. So the spine goes left and right. Kyphosis, you have an excessive curve in the upper thoracic vertebrae and in your cervix or your cervical vertebrae. Kyphosis shows an excessive curve in the upper thoracic and going into your cervical vertebrae. And this person looks like they have like a humpback. And then last, we have lordosis, which is an excessive curve in the lumbar vertebrae. It's really common in pregnant women, and this looks like a really excessive pelvic tilt. Kind of has that lifted butt look. Yeah. So each type of vertebrae will have distinct features, but all will have the same kind of main common parts. So the vertebral body is where the different vertebrae are going to stack on top of each other and be separated by those fibrous cartilages or the intervertebral disc. The vertebral foramen is where the spinal cord will run down your spine. Next, we have the spinous process, which again are the bumps you can feel on your back if you run your hand kind of down kind of the base of your neck going into in between your shoulder blades. You can feel the spinous process. Then next to the spinous process, you have your transverse process that kind of stick out toward the sides. And then finally, each vertebrae has 6 facets, each one with a process on it. No, sorry. Finally, we have each vertebrae has 6 facets, and each other facet is going to be on one of the processes. And then each of these facets are going to have hyaline cartilage for articulation to either one of the ribs or the vertebrae it's stacked with. So this is an image of the first 2 cervical vertebrae. The top 2 are C1, and then the bottom one is C2. This is the only time you're going to need to know the differences between the 2 numbered vertebrae. C1 and C2 have specific functions, and that they are articulated with the skull. So at the top, you have a superior view of C1, which is also called the Atlas. If you know anything about Greek mythology, Atlas was the guy that pissed off the gods and they made him hold up the earth. So the Atlas is what holds up your head. And then in the middle, we have an inferior view of C1. And then the bottom image is a superior view of C2, also called the axis. And then these two are really important because they're going to be what allows your head to rotate. So the base of the skull is going to sit on the atlas, going to sit on those 2 superior articular facets. And then the atlas is going to sit on top of the axis. On the axis, there's a structure called the dens that's going to stick up through the C1 vertebrae on top and attach to the head. And this is what's going to allow the head to rotate. Easy way to remember the axis is that the earth spins along an axis. Your head is going to spin along the axis. That's what the dens is for. So this is what the rest of the cervical looks like. So C3 through C7. Um, Notice that there is a transverse foramen and that the spinous process is split. Those are going to be 2 things to look for when you're trying to identify a cervical vertebra. You will not see the transverse foramen or a split spinous process on the other two types of vertebrae, only on cervical vertebrae. And then the body of the cervical vertebrae is also going to be very small because it does not support that much weight. It's only holding up the head. As you go down the spine, the body is going to get bigger because it has to support more weight. So next we have our thoracic vertebrae. Notice that the transverse foramen are no longer present and the spinous process is no longer split. And also the spinous process is going to be very long and narrow and points kind of straight down. It's also going to have a wider body as it supports more weight compared to the cervical vertebrae. One trick to kind of look at the thoracic vertebrae is from the lateral view or kind of straight on. And it kind of looks like the head of a giraffe with the spinous process kind of being the mouth, and then the transverse processes being the ears, and the body being like the main head. So yes, the transverse process. So yeah, thoracic vertebrae, think of a giraffe, thicker body, no longer see the transverse foramen, and a long and skinny spinous process. And then here we have the lumbar vertebrae. You can see that the body is even wider than thoracic vertebrae because it's supporting the most weight. The transverse process are also wider as well. And then the spinous process is thick and short and almost kind of square shape. And then for this one, how the last one looks like a giraffe, this one almost looks like a moose, with the spinous process being the nose of the moose, the transverse process being the antlers, and again, the body being the main head. Um, for the practical, you will need to be able to identify the different types of vertebrae using one of the models we have in lab, as well as these images. So here is another reference guide kind of describing the differences between the three vertebrae. So again, cervical is going to be C1 through C7. This one says C3 through C7. That's because C1 and C2 are the two special ones. But no, cervical is C1 through C7. And then you have thoracic, T1 through T12, and then lumbar, L1 through L5. So next we have our two fused vertebrae sections. We have our sacrum and coccyx. Really, all I want you guys to do for this one is be able to tell me this is the sacrum. Sacrum has 5 fused vertebrae. This is the coccyx. Coccyx has 4 fused vertebrae. You can really kind of see where the vertebrae are fused. In each one, you can see, you can kind of count them out. There's 1, 2, 3, 4, 5 here on the sacrum, and 1, 2, 3, 4 on the coccyx. Coccyx, also known as your tailbone. If you fall on it, it really hurts. Um, but yeah, that's really all I want you guys to know for that. Now we have finally reached the thoracic cage, meaning we are almost done. There's about 8 or so more slides after this one. So the thoracic cage is composed of the ribs, the sternum, and thoracic vertebrae. There are 12 ribs. 7 of them are true. They're called true ribs because they have a direct link to the sternum via those costal cartilages. 5 are false because they're going to kind of create a cartilage network that's going to all kind of fuse together and then they'll connect to the sternum. And then your last 2 ribs are floating ribs, so rib 11 and 12 are floating. That's because they do not connect to the sternum at all. They only connect to the thoracic vertebrae. The sternum kind of like a necktie, and it's broken down into 3 different parts. So you have at the top the manubrium, which is kind of like the knot of your necktie. And then we have the body, which is kind of the bulk of your necktie. And then lastly, we have the xiphoid process, which is like the tip of the necktie. And then remember that the cartilage found is called costal cartilage, and it's to help you have some compression. So if you get hit in the chest, you don't crack a rib every time. And then the spaces in between the ribs is just called intercostal spaces. And then the image on the right is kind of shows the body cut in half, and you can see the thoracic vertebrae and where the heart is in relation to the ribs, the sternum, and the vertebrae. So in this figure, you can see how the head and neck of the rib articulate with the vertebral. So in this figure, you can see how the head and neck of the rib articulate with the vertebrae posteriorly, and then kind of wrap and curve around to the sternum anteriorly. And then the angle of the rib is where the rib curves, and then everything else in between where it curves is going to be known as the rib shaft. And this is another view of the articulation of the rib and thoracic vertebrae. You can see the articular facets on the tubercle of the rib, laying underneath the ligaments that are going to hold the two bones together. And also the head of the rib at the superior costal facet and the small white line between the head and costal facet is hyaline cartilage. And then here's another realistic image of the rib. You can kind of see that angle of the rib, the costal groove. Yeah, I won't really ask you too much on this. I know it says know everything. But yeah, all I need you to do is really tell me this is a rib, kind of know where the head and neck is, and then kind of know the difference between a left and a right rib. Because again, the head's going to be where it attaches to the vertebral column. And so it's only really going to be able to go kind of run in one way. All right, so we're almost done, guys. So lastly, we're going over the fetal skull. So it has all of the same bones as your adult skull. However, the plates or bones of the skull are not fused like the adult skull. So they don't have those sutures. So what they have are the fontanella, which is just another word for the soft spot. So that soft spot is going to be where the bones will eventually fuse together, but to allow an easier birth, the skull is soft and movable. So the posterior fontanella is going to be in between the occipital and parietal bones on the posterior side of the skull, and then the anterior fontanella is between the frontal and parietal bones of the skull on the anterior side. And then here's just a lateral view. And you can see we have a sphenoidal fontanella, which is by the sphenoid bone. And then lastly, we have the mastoid fontanella or fontanelle. You hear them both, fontanelle, fontanella, same thing. But yeah, the mastoid fontanelle is closer to the mastoid process on the temporal bone. And this is going to be where the occipital bone connects with the temporal bone on the adult skull. And then here is just another cadaver image of a fetal skull. Again, use the color images to kind of identify where the bones are and then kind of be able to tell me which bone is which on a model. And here's just a lot of view. All right, so that's it for the axial skeleton. I know this is late. I went kind of fast. I'm gonna go over some stuff again in lab this evening. And yeah, so I think in lab, what I'm gonna have you guys do is just kind of work together to build out a skeleton so you can guys get a sense of how bones connect, where they go, and kind of get used to looking and identifying the bones. All right, that's it for me, guys. I will see you in lab.